In this video, we are going to implement UNET using TensorFlow, where we are going to replace its encoder part with a pre-trained RESNet50 architecture. Hello friends, this is Nikhil Tomar and you are watching Idiot Developer. So let's start the video. Here we have our model.py file, and in this file we have imported all the libraries and the classes which we require. In the first line we have imported all the layers which we need. In the second line where we have imported the model class, and in the third we have the RESNet50 class. This is the architecture. It's already trained on the ImageNet classification dataset, and we are going to use its architecture as the encoder for our UNET. So this is the UNET architecture, and we are going to replace this complete left part with this RESNet50. So first of all, we try to implement the basic convolution block. Okay, so let's start with that basic convolution block. This convolution block basically uses two 3x3 convolution, each followed by a ReLU activation, and within this convolution and the activation function, we are going to introduce the batch normalization. In the original UNET there is no batch normalization, but later researchers started adding batch normalization as it's improved the performance of the UNET. So let's start with that. Con block, first is the inputs, next is the number of filters, that is the number of feature channels, the output number of feature channels. X con 2D. In first input is the num filters, second is a 3x3 kernel, and padding we're going to say same, and its input is the inputs. Next is the batch normalization, and its input is the output of the convolution block, and third is the ReLU activation, and its input is the output of the batch normalization. And like this we're going to repeat these three lines again, and here the input is going to change to the output of the ReLU activation. So this block is complete and it's going to return the output of the second ReLU activation function. Okay, so let's start building the model. Let's say build RESNet50 UNET, and it's going to take the input shape as the argument. So first of all we're going to build the input layer. Inputs is equals to input, and within this we're going to say give it input shape as the parameter. So we have our input layer ready. Next we are going to call the pre-trained RESNet50 model. Pre-trained RESNet50 model. Okay, RESNet50 is equals to RESNet50. So first of all, include top is a parameter in this class, and we're going to say it to false. Include top false basically means that we don't want the classifier layers in it, we only want the convolution layer. So that's why we set it to false. Next is the weights, as we don't want the blank architecture, we want it with the to be initialized with its weight. So that's why weights should be shared to ImageNet. And next is the input to this architecture. Input tensor is equals to the input layer we have specified here, this input layer, and we're going to paste it here. So we have our RESNet50 ready. Let's print its summary and see. Okay, what's the name of the file? I forgot. Okay, it's model.ppy. Okay, the mistake is that I haven't called this function anywhere. So let's write this main function, input shape, let's say 512 by 512 by 3. Okay, and model is equals to build RESNet50 input shape. So we call it. Now again we're gonna run this program. Okay, so you can see we have the summary of the entire RESNet50 architecture, which is initialized with the ImageNet weights. So input layer is 512 by 512 by 3, and it goes till down to till 16 by 16 by 2048. So this is the result of saying include top equals to false. Okay, we don't have the classifier layer here. So now next is that we have to find the skip connection from these layers, and these names are going to be really important for us. So let's start with that. Let's say encoder here. Spelling mistake. Encoder. And within encoder we already have this pre-trained model as the encoder, but here we're going to extract the skip connections, and these skip connections are basically, let me show the architecture. Okay, so these are the skip connection 1 2 3 4. So there are 4 skip connections, and these are basically the shapes which we need to match in the decoder part. Okay, so we're going to find the exact shape skip connection, because the shaping is important, otherwise they won't concatenate. And if some shaping problem might be there, like 1 to 2 pixel shaping that doesn't match, then we're going to pad them with 0 to make sure that their size match up properly. So first of all, you need to provide the name of the architecture, that is RESNet50, then dot and get layer function, and inside this we need to provide the name and say output. Okay. And like this we need 4 skip connection. So I've copied this, and we're going to change the name S1 S2 S3 S4. So 4, and first is going to be the size of the 512 by 512, because the input size is this 512 by 512. After that they are going to reduce by 2, they are going to be half. So let's see first feature map with the size of 512 by 512. Okay, so input size is 512 by 512 by 3, and after that we have a 0 padding, and then 256. Okay, so first feature is basically the input image, otherwise we won't have and the shape matching with this. Okay, so let's our first skip connection is the original input image. Second is going to be, so let's write here 512. Second is 256. So now we're going to find an activation function with the output shape 256 by 256. Okay, so we can see 258, it is 0 padded, we need 256. Here we have 256 by 256. This is the height and width. So we're going to copy this con 1 underscore reload and paste it here. And let's say this 256, and next is 128. We're going to go scroll down and see the 128 here. Okay, so you can see 128 by 128, and this is also an activation function, output of an activation function. Let's specify this here, and we're going to write 128 here to remember. And the last is 64 by 64. Let's go. Okay, so we find this con3 underscore block 4 underscore out. So let's copy this and paste it here. So we have our all the skip connections ready. Now let's once again print the shape. Check. We're gonna run this program and check the shape. So shape matters. Okay, so you can see first shape is 512 by 512, second is 256 by 256, third is 128 by 128, and the fourth skip connection has a shape of 64 by 64. And we can see the feature channels, this number of feature channels increases, and at the last we have 512. So now we have our skip connections ready. Next we need is the bridge. Where is the architecture? Okay, here, this last feature here, it is we're going to extract it from the that pre-trained encoder only. Let's say bridge. Some people also call it bottleneck part. Let's call it bridge b1 equals to RESNet50 dot get layer, and here the shape is going to be 32 by 32. Let's again go to this architecture and find the shape. The con4 underscore block 6 underscore out. Let's paste it here and get its output. So we have the bridge ready. Now we need is the decoder blocks. So we have 4 encoders blocks, that is 4 skip connection. So we need 4 decoder block. So we're gonna build the decoder block. So this is the right part is the decoder, and it has 4 decoder blocks, and in each decoder first is followed by up convolution, a 2 by 2 up convolution, that is transpose convolution, and after that it is followed by the concatenation with the skip connection, and then the convolutional block, that is 2 3 by 3 convolution. So let's build a decoder block first. First is the input feature map inputs. Second is skip features, feature full of skip connections. Third is the number of output filters. So first is the convolution, the transpose convolution, con 2D transpose, and you take number of filters first, then a kernel size of 2 by 2, writes of 2, and padding is equal to same, and its input is the inputs. Next is the concatenation of this upsampled feature map, that is the output of the transpose convolution and the skip connection feature map. That's why their shape need to be matched exactly. That's why when we are finding skip connection, we check their shape. So here we're gonna say x to skip features. Okay, so next is followed by the convolutional block, basic convolution, x and the number of filters, and it's going to return. Okay, so we have our decoder block ready. Next it's going to follow the decoder layers, that is d1 is equals to decoder block. So its input is the output of the bridge d1, and the skip connection. So bridge is 16, no, not 16, it is 32. So this 32 is will be gone through this transpose convolution, and it became 64, and it need to concatenate with the feature map with the size 64. So S4 has a size of 64, so we're gonna say S4, and the number of output channel, let's say 512. Okay. Like this we're gonna have another decoder block, and we're gonna name it D2 out. So the input of the decoder block D2 would be D1, that is output of the decoder block D1. Here we're gonna have S3, because now output feature map is of size 64. Here we have size of 64, and here 64 would become 128, and we have to concatenate it with S3, and it became 128. The number of filters we can change to 256, and like this we're gonna have 2 more decoder blocks, D3 and D4. Let's rename them to D3 and D4. And so D3 would have input D2, S2 and 128, and the output size would be 256, and this is the last decoder block, and its input would be D3, S1 has the skip connection, and number of output filter would be 64, and its output size would be 512 by 512, because both the height and width are the same. So that's why I'm only writing one parameter here. And at last we have the output layer, that is a 1 by 1 convolution with the number of classes as the number of filters. So let's say outputs equals to 1 to 2D, and in case of binary segmentation we're gonna have 1, because in binary segmentation we have one class, that is the main object, and other is the foreground class. So we're gonna have 1 with 1 by 1 as the filter kernel size, padding is equals to same, and activation is going to be sigmoid. and input is going to be d4. Okay, we're gonna have this ready. But in case of a multi-class segmentation, like you have in multi-class 5 classes, so you're gonna say 5 here and you're gonna say softmax here. Okay, so this is going to change in case of multi-class. Let's build the model. Model is equals to, we're gonna call the model class inputs, outputs, and we're gonna return the model here. And we already called the model, and we're gonna print the summary of the model. So let's run it again and see for any error or anything. Okay, so you can see the output is 512 by 512 by 1. Let's go back to the starting of this network and see the input size. Okay, so okay, we have okay. One thing, we have to remove this part. We have to remove. We don't. Let's do it. Open another terminal and close this. Okay, let me zoom in. Yes. Okay, let's go to the starting of this network. So you can see TensorFlow messages. You can see my GPU also. That is GTX 1066 GB. It's very low kind of GPU for me now, but don't worry, it's enough for this YouTube demonstration. So you can see in the model summary, that is the RESNet50 UNET architecture. It's take the input as 512 by 512 by 3, and it goes through the entire RESNet50 architecture. Then it passes through all the decoder blocks. It passes through the transpose convolution, upsampling the features, then passes through the convolution block until last it get to a size of 512 by 512 by 1. And these are the number of parameters in this architecture. So that's all about this entire RESNet50 UNET architecture. So it's basically a unit with a pre-trained encoder, and for the encoder we have used RESNet50. I also have other two videos where I have used VGG16 and VGG19 as a pre-trained encoder for the unit. You can also watch that video. You can check that description for the links. So I hope you find this video useful, and if you find this useful, make sure you like it and subscribe the channel. Thank you. Have a nice day.